So we're going to look at an example of a projectile problem, specifically a horizontally launched projectile. And this is on page 72, number 27. Okay, so it says, a ball thrown horizontally at 22.2 meters per second from the roof of a building lands 36 meters from the base of the building. How high is the building? So if you sketch it out, this is what we're looking for, the height of the building. It's launched out at 22.2 meters per second, goes out like this, and it lands 36 meters from the base, like this. Okay, so this is a horizontally launched projectile. Like any projectile problem, we're going to break it up into horizontal and vertical components and look at the motion in two separate accounts. So I know that the object lands 36 meters horizontally away from the base of the cliff, so delta x is 36. I also know that it was launched horizontally at 22.2 meters per second, and the acceleration in the x direction is always 0 if we neglect air resistance, because there's nothing to speed it up or slow it down in that direction. Delta y is what we're looking for, the height of the building. Since it was launched horizontally, it was not moving up or down at launch, so VO in the y direction is 0. And AY, as always, just like in any free fall, is negative 9.8 meters per second squared. Now, the key to solving these kind of problems is to look at the two accounts of the information, the horizontal and the vertical, and look at which one has all of the information. Okay, so the vertical does not, because the delta y is missing, but the horizontal information is all completed. So I can use the equation for delta x, the position equation, or displacement equation, and use this to solve for how long it's going to be in the air. Now the acceleration in the x direction is 0, so I have 36 meters equals 22.2 meters per second times t, and I can solve this for t. So I have 36 divided by 22.2, and I get 1.62 seconds. So that was easy enough to find. Notice I only use the horizontal information when I use the delta x equation. Now, since I have the time, I'm going to use that time with the delta y equation and solve for whatever's left. So VOT plus 1/2 AT squared. Okay, in the y direction, the initial velocity is 0, so this term crosses out, and I get delta y equals 1/2. The acceleration is negative 9.8 meters per second squared, and the time is 1.62 seconds. We're going to square that. So 1.62 squared times 4.9. I get negative 12.86. Delta y equals negative 12.86 meters. So that's how far the object fell, okay, the ball. So instead of saying it's negative, we can call the height just the positive amount there at 12.86 meters high, because it fell 12.86 meters downward according to this. So here's our answer.